Okay, the first type of quadrilateral we're going to get into is called a parallelogram. Parallelogram has two sets of opposite sides that are parallel, so it's right in the name. This is opposite sides are parallel. Okay, there's going to be some other properties that we get into, but this is the definition of a parallelogram. The definition says that opposite sides are parallel. So what we want to do is we want to fill in the front of our packet with parallelogram. Okay, so we're going to put that right here. Okay, parallelogram. Now these lines are gonna be ways for us to get from a quadrilateral to saying that it's a parallelogram. So the very first way that we can do that is by showing that opposite sides are parallel. So if I have a quadrilateral and I find out that its opposite sides are parallel, that allows me to say it's a parallelogram. Okay, so if we want to construct a parallelogram, we're basically going to make some starting lines. Okay, so I'm going to start here, and I'm going to want to make a line that's parallel to this one up here. Okay, so whatever point I want to go through. So let's say I want to go through this point. Okay, so that's going to be the end point of my parallelogram. So what I'm going to do is get my compass. And we're going to make a circle. And we're going to make the same circle from our other end point here. Okay, so I want to recreate this angle up here. So if you notice, this is where my angle is on the line. So I'm going to go from there. I'm going to measure how far it is from there to this other spot that's meeting the other line. Okay, so it's that far away. Actually, I'm a little off here. There we go. Okay, so what I'm going to do is I'm going to recreate this from here, because this would correspond to this point. So I'm going to bring it up there and mark that same mark here. And then when I connect to these, it's going to give me parallel. Okay, and then I can do the same thing to make another line that goes through here that's parallel to this one. So let's make a point where I want to go from, right here. Okay, I'm going to make a circle, come over and make the same circle from here. And now I want to know how far this point is from this other point. So I think that's about right. Okay, I'm going to recreate that over here. Okay, so my lines are a little too wide, but that's the construction that you can do. And there's going to be a different construction we can do after we find some properties out about parallelograms. Okay, but this would be if you only knew that parallelograms had opposite sides or parallel. This is the construction you would do. So let's start looking at parallelogram properties. Okay, in order to do that, we're going to use our definition of a parallelogram to come up with some congruent triangles. Okay, if I know that these lines are parallel, so this one is parallel to this one, and these are parallel, okay, I'm going to be able to say that this angle is congruent to this one because they're alternate interior. I could also say that this angle is congruent to this one because those are alternate interior angles on the side lines. And then, of course, this segment is congruent to itself by reflexive. So these triangles are congruent, which means all their parts that correspond to one another are congruent. Some of those parts would be angle D and angle B are going to be congruent. Okay? These would be congruent too because I'm adding two congruent angles up. So what I can say from that is that opposite angles in a parallelogram are always going to be congruent. This side over here is going to be congruent to this side over here. Okay? I could say the same with this. Okay, these sides. So opposite sides of a parallelogram are congruent. If I look at the top and bottom lines and use this side as a transversal, these angles here, so the entire angle here and this angle, they are consecutive interiors, so they are supplementary. They're 180 degrees added together. Same with these. Okay, any set of consecutive angles, so the ones that are next in sequence together, are supplementary. Okay, and the last thing we could do deals with the diagonals. If I put the other diagonal in here, I could get some different congruent triangles. This angle is still congruent to this one. Okay, and now this angle would be congruent to this one. Since I know that these opposite sides are congruent, these triangles are going to be congruent. And I could do a similar thing to get these triangles congruent. But what this does for my diagonals is it allows me to say that these pieces are the same and these pieces are the same. So the diagonals bisect each other. So opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other, and consecutive angles are supplementary. So let's use this quality here to come up with an easier construction of a parallelogram. So we'll do that down here. I'm still going to start with the two sides that I want to start with. But now all I need to do is recreate some distances to ensure that I get opposite sides that are congruent. So I want a side that is this long. Okay, from here and I want a side that is also this long. From this endpoint. So where they cross, I can connect that to complete my parallelogram. It's right there, and back over to here. Okay, and that's a little bit easier of a construction than this original one. So let's look at some example problems. just make this a little smaller here. Okay, so if we use all these properties, I should be able to fill in any of these missing parts here. So let's start with just an easy one, just the angles. Since I know that these are supplementary, so this angle and this big angle, I know that 100 plus 25 is 125, which means I am missing 55 degrees to make 180. Since these are parallel, this angle here, since these are parallel also, this angle is going to be the same as this one. This one will be the same as this one. And these opposite angles are congruent in a parallelogram, so this is also 100 degrees. And all these should add up to 360. Over here, this is 105 degrees. This is vertical with that. These are supplementary, so this has to be 75 degrees. This also has to be 75 degrees. 75 and 75 is 150, and in this triangle I know I need 180, so that makes this 30 degrees. This is alternate interior with this, and these together make 125, and that has to be supplementary with this total angle over here. So I need a total of 55 over here. Since I have 30, this is 25. This is also 25 then. These have to be the same as what I had down here. Since this is 5, this other piece of that same diagonal is 5 because the diagonals are bisected. So this would be 3. Opposite sides are congruent, so this is 8. And this is 4. I want to look at how we can use proofs, parallelograms and proofs, and I want to demonstrate again how to do flow proofs because I think they demonstrate more. It's a little easier to see that you're using a logical argument because they demonstrate kind of what step is leading to the next one. So we start with our givens. Our givens start in their own box. So I've got a parallelogram. That's what this symbol means. So when you see that, that means DFEG. DFEG is a parallelogram. So I get all those properties of parallelogram. Okay, this is given. So what that gives me is I get opposite angles are congruent. I get opposite sides that are congruent. I get diagonals that are bisected. And I get consecutive angles that are supplementary. If I'm trying to get GHE, which is this bottom triangle, congruent to FHE, oh, that's a mistake.